Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to look at the first part of section 11.2, where we will just learn a little bit more about probability. So when we talk about probability, what it is, it's the measure of how likely something is to occur. What is the chance that if you buy a lottery ticket, you are going to win? Okay. What is the chance if you're having a baby that it will be a boy or a girl? What is the chance if you roll a number cube that you will get a 1? So probability is just how likely something is to occur. Now, when you look at probability, one of the key ideas is called the sample space. The sample space is a list of everything that can happen. So like if you flip a coin, your sample space is heads or tails. What can happen? If you roll a standard number cube, your sample space, you could get a 1, 2, 3, 4, 5, or 6. So that's what that would be. If you spin a spinner, okay, obviously this is a little bit hard to see because it's black and white print, but if one section was red, one was blue, one was green, one was yellow, what could happen if you spin a spinner? You could get red, blue, green, or yellow. That's what the sample space is. Now the sample space is always the denominator of the fraction when you're calculating probability. Now some key words as you're talking about probability, if somebody says something's impossible, that means that it has to be 0%. There's no way that can happen. So like, what's the chance of rolling a 7 on a number cube? It's impossible. A standard number cube does not go up to 7. As likely as not, if you use those words, it means it's exactly 50%. So if you flip a coin, what's the chance of getting heads? Well, there's only 2 options, so the denominator is 2. Heads is one of them, so 1/2 is 50%. Certain means it has to be 100%. If you roll a standard number cube, what's the chance that your number is lower than 10? Well, all numbers are lower than 10, so that would be a 100% chance. When something has equally likely outcomes, that means that there's a fair chance. So if you flip a coin, heads and tails are equally likely. If you roll a number cube, where it would not be equally likely, let's say you're playing a board game and you have this section is half of the spinner and these 2 sections are like that, this would not be equally likely. You would have more of a chance of landing in this section versus those 2. But if you have a board game spinner and all 4 sections are the same, they would be equally likely, okay? So now what you have to do when we're going to probability, you start off with a fraction. The number of possible outcomes, so again, that sample space, that's your denominator. What you're looking to happen, that goes on the top. Your probability is always written as a fraction, a decimal, and then a percentage. So let's do some. Each letter of the word probable. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters in the word probable. So that means your denominator would be 8. Okay. Each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card is a consonant? So what that means, your top is how many consonants are there out of the original problem. A consonant means it's not a vowel. Vowels are A, E, I, O, and U. Okay, unless they specify Y, you never count Y. So I would have to cross off any A, E, I, O, or U. So I cross off 3. How many letters are consonants? 1, 2, 3, 4, 5 out of the 8. I cannot reduce the fraction. If I turn it to a decimal, 5 divided by 8 is 0.625, which is 62.5%. Okay, here's another one. In a box of 25 switches, so picture like a light switch, 3 are defective. What is the probability of randomly selecting a switch that is not defective? So your denominator is the sample space. There are 25 total switches to choose from, so the bottom is 25. What your top is how many of them are not defective. Well, out of the 25, 3 are defective. So if I take 25 minus the 3 defective, that means 22 are not defective. That would be your probability. Now to turn it into a decimal, top divided by bottom, 0.88. So if you are just reaching into that box, you have an 88% chance that when you grab a light switch, it is going to work. Okay, now here's where it gets kind of cool. Let's say that you roll 2 number cubes. You actually have 36 different things that can happen because the first number could be a 1, 2, 3, 4, 5, or 6, and the second number could be a 1. First number could be a 1, 2, 3, 4, 5, or 6. Second number could be a 2. And that goes all the way through where the second number could be a 1, 2, 3, 4, 5, or 6. So there are 36 different things that can happen when you roll two number cubes. So your denominator would be 36 because those are all the possibilities. Okay, if all the numbers are equally likely, what is the probability that the sum, remember sum means that you're adding, that the sum is 6. So we go ahead and look through the option. 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4 is 6, 1 plus 5 is 6. So 1, 2, 3, 4, 5 out of the 36. Now if I go 5 divided by 36, it's 0.138 repeating. So if I say 0.139, now to turn it to a percentage, you move that decimal twice. So it's approximately 13.9% chance that when you roll a number cube and add the two together, you'll get a sum of 6. Okay, next one. Two number cubes are rolled. Here is a list of your possible options. What is the probability? So out of the 36, how many have the difference between the two number cubes is 4? So if you take the two number cubes and you subtract, can you make a 4? Well, 5 minus 1 is 4. 6 minus 2 is 4. Here, I can't make a 4. I can't make a 4. Ooh, 5 minus 1 is 4 and 6 minus 2. So 4 out of these 36 options, I can take the two numbers, find a difference, so you can subtract, and I'd have a difference of 4. I can divide top and bottom by 4, so it's 1 over 9. 1 divided by 9 is 0.11, so there is an 11% chance that if you roll two number cubes and you look at the numbers, you're like, hey, I could subtract them and get a 4. Let's keep on going. These are a lot of notes today, but it's kind of fun. Let's look here. So same thing. Okay, there are 36 options. We are still going ahead and rolling a number cube. So this time they're specifically saying, what is the what is the probability that the difference is 6? So remember, difference is minus. We have 36 options. If you look through here, the two numbers that are the furthest apart numerically are 6 and 1. If I take 6 minus 1, I only get a 5. So there are no combinations here where you could take the numbers and make a 6. So you would have 0 over 6. You still write it as a decimal. 0 divided by 36 is 0. You still write it as a percentage. 0 as a percentage is 0%. That means it is impossible to take two number cubes, roll them, and have a difference of 6. So this is what it would look like if it's something impossible. You still have to state fraction, decimal, percent. Okay, a red number cube and a blue number cube are rolled. If all the numbers are equally likely, what is the probability of the red cube having a greater value? So here we need to know which one's red and blue. So let's say this is red, this is blue, this is red, this is blue, red, blue, red, blue, red, blue, red, blue. Okay, so the red, so we want to know the probability out of the 36 that the red cube has a greater value. So here, 1 and 1, they're the same value. If the first one is red, 2, 3, 4, 5, and 6, they are all greater than 1. So 1, 2, 3, 4, 5 from that first column. 1 is not bigger than 2, 2 is not bigger than 2. But 3, 4, 5, and 6 are all bigger than 2, so 1, 2, 3, 4 of those options. 1 is not bigger than 3, 2 is not bigger than 3, 3 is not bigger than 3. But 4, 5, and 6 are all bigger than 3. 1, 2, 3, 4 is not bigger than 4, but 5 and 6 are. 1, 2, 3, 4, 5 is not bigger than 5, but 6 is bigger than 5. Now here, if I'm looking for the red to be bigger, 6 and 6 is the closest we get, and 6 is not bigger than 6. So out of those 36, 5 plus 4 plus 3 plus 2 plus 1, there were 15 options where the red number cube would have been greater than the blue number cube. I can divide both top and bottom by 3. So 15 divided by 3 is 5. 36 divided by 3 is 12. 5 divided by 12 is 0.416 repeating. So I'm going to say about 0.417. So there's a 41.7% chance that if you roll a blue and a red number cube, that the red number cube will have a greater value than the blue. Okay, one cool thing when you're doing probability, if you add up all of the items of a sample space, you should always get 1. Now that's called a complement, and a lot of it is common sense. So let's say that I say there's a 30% chance of rain today. Well, that means that there's a 70% chance that it will not rain. So this, if I take them in decimal form, 0.3 plus 0.7, it equals 1. That's what they're talking about. So you have to think of complements. If I'm talking about rolling or flipping a coin, I have a 50% chance of getting heads. I also have a 50% chance of getting tails. When you flip a coin, those are your only two options. 50 plus 50, there's 100% chance of what can happen. Okay, so that's what they mean when they say a complement. You add everything up to get your 100%. All right, next, there are 25 students in a study hall. The table shows the number of students who are studying a foreign language. So there are 25 students in the study hall. The total is going to be your denominator. In the study hall, 6 people study French, 12 people study Spanish, 3 people study Japanese. So 6 plus 12 plus 3. So in that study hall, 21 students are studying a foreign language. What is the probability that a randomly selected student is not studying a foreign language? So your numerator, we're looking for students who are not. There are 25 students in the class, 21 study a foreign language, so that means 4 do not. 4 divided by 25 is 0.16. So there is a 16% chance that if you randomly select a student out of that study hall, they would say, hey, I don't study a foreign language. Now this next question, this is getting you ready for something that is coming up. So it's kind of like a little sneak peek. We will see more of this type of question in 11.3. 2 integers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 options are randomly selected. The same number may be chosen twice. What is the probability that both numbers are less than 9? 10 is not less than 9. 9 is not less than 9. So when you choose a number, you have 10 options. 8 are smaller than 9, okay? So 8 out of the 10. But then they're saying that you're choosing twice. So you choose a number, then you go back and you choose again. You can do the same number twice, so there's still 10 options. There would still be 8 numbers that are less than 9. So if you do the same thing in an experiment more than once, you multiply those probabilities together. But before I multiply them, I can reduce 8 over 10. This would be 4/5. This would be 4/5. What I did is I just divided top and bottom by 2. When you multiply fractions, remember you take top times top, bottom times bottom. 4 times 4 gets me a 16. 5 times 5 gets me a 25. So that's the fraction. You always have to give your probability is a fraction decimal percent. 16 divided by 25 is 0.64, which would give me a 64% chance that if you have the numbers 1 through 10, and I'm like, hey, randomly choose a number, 1 through 10. And I say, hey, choose another number. 64% chance that both of your numbers are going to be less than 9. And 2 more questions, and we get to call it a day for notes. So each student received a 4-digit code to use library computers. No digit can be repeated. Megan received the code 7654. What was the probability that she would receive a code of consecutive numbers? Well, the deal here, when you have a code or something like this, your sample space is going to be a permutation or a combination. In order to figure out how many possibilities there are, we can't list them out. That's why in 11.1 they taught us about permutations or combinations. So when you have a scenario like this, first thing is to figure out what you need. If you're getting a 4-digit code to use in order to use the library computers, obviously the order matters. Okay, so Megan can't go 5746 and the computer will be like, hey, you use the same numbers. Okay, they have to be in that order. So it does matter. So the number, sample space, it's a 4-digit code. Remember when you have digits, there are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 possibilities. Your code is 4. So if I'm figuring out how many numbers are in the sample space, it's outside as a factorial, outside minus inside. 10 minus 4 is 6 factorial. So it's 10 times 9 times 8 times 7 times 6. I'll stop there, leaving it as a factorial. That way, the bottom will cancel. So your sample space, how many possibilities are there? It's 10 times 9 times 8 times 7. There are 5,040. So that's the denominator, okay? That's how many possible codes there are. Now, favorable. we're looking at the probability she gets a code of consecutive numbers. So like 0, 1, 2, 3, 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. Now I couldn't go any further because we don't have a 10. When you're doing digits, oh, sorry about that. When we do digits, you go 0 to 9. But notice the code that she got was going backwards, 7, 6, 5, 4. So you have to realize this could be 3, 2, 1, 0. This could be 4, 3, 2, 1, 5, 4, 3, 2, 6, 5, 4, 3, 7, 6, 5, 4, 8, 7, 6, 5, 9, 8, 7, 6. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 possible 4-digit codes using the numbers 0 through 9 where you have consecutive numbers, meaning that they're just in counting order. So to find the probability, I have 14 that work out of the 5,040. I can go ahead and simplify that. So if I simplify, I can divide both top and bottom by 14. So I'd have 1 over 360. Go ahead and turn that into a decimal, which is 0.0027 repeating. So 0.003. So there's about a 0.3% chance that you would have consecutive codes for a library passcode for the computer. Okay, let's look at the next one. A DJ randomly selects 2 of 8 ads to play before her show. 2 of the ads are by a local retailer. What is the probability that she will play both of the retailer's ads before her show? Okay, so this is a combination. There's not like an award for being played first or second, okay? So it's a combination. There are 8 ads. She's selecting 2. So combination 8 goes on the top, 2 goes on the bottom. 8 minus 2 is 6. So when I go ahead to do this, 8 times 7 times, I'm going to keep the 6. 2 times 1, 6 factorial. This cancels this. 8 times 7 is 56. 2 times 1 is 2. 56 divided by 2 is 28. So it's 28 different possibilities. Find the number of favorable outcomes. So if she's picking the 2, she could have, there would be 2 options because she could pick the first one and then the second one because the order doesn't matter. Then she could pick the second one and then the first option. So if you think about it, she would have 2 options out of the 8 the first time she draws, right? Because there's 2 ads by the local retailer out of 8. Then, when she goes ahead and picks the second time, there would only be 7 options. Only 1 would be by that retailer. So 2 times 1 is 2. 8 times 7 is 56. So there would be 1 over 28, which already matches that denominator. So now if I want to turn it into a decimal, 1 divided by 28 is 0.0357, so 0.036. So there's about a 3.6% chance that when the person, the DJ at the radio, when they pick their ads, both of the ads would be by the local retailer. So you'd have back-to-back Kentucky Fried Chicken commercials. That's what they're talking about. Okay, so your assignment today is actually a worksheet, so don't worry about the book assignment. I hope you enjoyed learning more about probability, and I'll talk to you later.